Hello folks, this is a tutorial on our specific question on position vector and relation with velocity. So here we go, here's the question. A particle moves from 0, 0, which is the origin, with initial velocity of 3.5, 0 meter per second and constant acceleration of minus 1.7, minus 2 meter per second. When the particle reaches its maximum x-coordinate, what are its velocity and its position vector? So there are two things we need to find, that's its velocity and its position vector when it reaches maximum x-coordinate. So let's begin the solution. Since the particle reaches maximum x-coordinate, it means its final velocity is going to be 0. So v equals 0. Now we're gonna use a simple Newton's formula to calculate the time that it took to reach the maximum x-coordinate. So using the formula v equals to u plus at, we get v, which is the final velocity, we know that is 0, is equal to 3.5, which is the initial velocity u, plus minus 1.7 times time. So why did we use minus 1.7 in place of acceleration? Since we have two coordinates for acceleration, that is minus 1.7 and minus 2, but the minus 1.7 is the x coordinate, hence we use the x coordinate to find the time that it takes to reach maximum x. So moving on, solving that, we get t equals to 2.05 seconds. So that's the time that is taken to reach the maximum x. Now let's compare this particle to a car coming to rest, which is known as retardation. A car coming to rest is called retardation. As we can see in the question, the particle has a negative y component of acceleration, which means it retarded on y direction. Likewise, we can also say it accelerated on negative y direction. Hence, we'll solve for the y component of final velocity, which is given by v equals to a times t, which is a simple velocity formula. So solving this, we have minus 2 in place of acceleration, which is the y component of acceleration, times time that we have already calculated in the previous slide, which is 2.05 seconds. So solving that, we get a final velocity of minus 4.1 meter per second. This is the y component of final velocity, and we already know the x component of final velocity is 0. Hence the final velocity's vector representation is 0, minus 4.1 meter per second. Now for positions, we have another Newton's formula, which is v squared equals to e squared plus 2as. And for those folks who don't know what s is the distance moved. It's a variable used for the distance moved. So as we calculate on the x direction, we have final velocity 0, initial velocity is 3.5, and plus 2 times acceleration, that's on the x. So we need to take the x component, which is negative 1.7 times the distance. So solving this, we get the distance equals to 3.6 meter. And for the y component, we use the same formula. For the velocity, final velocity, we have negative 4.1 squared. That's the value we calculated a couple of slides back. And then the initial velocity is 0 plus 2 times acceleration is the y component of acceleration, that is negative 2 times the distance. So solving that, we get s equals to minus 4.2 meters. Hence the position vector at maximum x point is 3.6 on the x component and negative 4.2 on the y component.